Hi guys, today is January 31st, and some of them may kinda know what is this all about, right? Because I, I don't do weekly LeetCode contests in bi-weekly LeetCode contests that's because of some reasons, but one thing that I can do is January challenge. And because today is the last day of January, we'll try to do the same thing that we did last month, but we'll try to do it a little bit faster this time, I guess. So we have General Lead Coding Challenge 2021. Now I don't remember like what was the first month when LeetCode has had a long challenge, monthly long challenge. So it may or may not be like entire year of challenges already. But as you can see on the left hand side, like these are the times we took the previous time, right? So for December challenge, it was absolutely grind to like 5 hours, 31 problem. And we'll try to do it a bit faster today. Unfortunately, I'm not starting exactly at the last day, right? At the beginning of the last day, we are like 8.5 hours late. So we don't have that much time to complete all problems. Yeah, I think we can get started and we'll have like way to compare with how we were doing previous time. The only issue is that I kind of forgot how to use that program, but I guess that you just press space a couple of times. And also it takes a bit of my screen. Yeah, okay, let's jump into it. Check array formation through concatenation. You're given an array of distinct integer array and an array of integer pieces, where the integers and pieces are distinct. Your goal is to form array by concatenating the arrays and pieces in any order, or you're not allowed to reorder the integers in each array pieces I. Okay. So basically we want to construct array from pieces. That's kind of, okay. Yeah, and we'll do it in Python this time, right? Also, what are the editor settings? I kind of like, no, okay. Still no. No, clearly not that one. No, still no. Okay, I guess they don't have like my favorite theme. So yeah, how can we do it? Like integers in pieces are distinct, right? So we can just do for piece in pieces if is no actually. If piece 0 equals array 0, and it means that we basically have to go this way. So so we have to check that it's correct prefix and self can form array. We'll add a base case. So if array is empty and pieces are empty, return true. Okay. And self-conform array will get from that point until the end. And I believe it's not like very efficient. Or actually, yes, we'll need like to remove that piece from pieces. Other pieces are what? Are pieces before I and pieces after I plus 1 inclusive. So here we have other pieces. Can actually do this like pass it straight to this function. And this is kind of it. If we don't find a matching piece, that we can just return false. Okay, so it was a bit slow, but again, we were talking a bit, so that's okay. Find a corresponding node of binary tree in a clone of that tree, given two binary trees, original and cloned, and given a reference to a node targeting the original tree. Return the reference to the same node in the clone tree. Okay, so there are like, oh, okay. I'm guessing, all right. So if original equals target, return cloned, like we would like to do I'm trying to think like what is the best way to code it. And also to get a bonus, right? So want to find what is what. Okay. Like what we can do is the following. No, but I don't want to like, okay. I don't want to generate an order traversal entirely. What is the expected way to do it without extra memory? Can you do it just like this? So if no, not original, what if we return none here, right? And here we return or. How about that? So idea is that we search in the left subtree in the right subtree. And because we take or and one of the values is none, by default, it looks like it should return what it's supposed to return. Let's see. Okay. So we actually did better on that segment. Hello? Oh, okay, it's loading. Beautiful arrangements. Suppose you have n integers labeled 1 through n, a permutation of those n integers perm. One index is considered beautiful arrangement if for every I, either of the following is true. Permutation I is divisible by I, or I is divisible by permutation I. Number of beautiful arrangements that you can construct. That sounds complicated unless n is very small. 15 is not small enough because 15 plus 15 means that we can't iterate through all permutations. Let's think what can be the supposed way to do it. But 15 is enough to have like bit masks of what integers are present and what are not present, right? And one thing I don't like about such like combinatorics problems is that you rarely can get an adequate balance on runtime, and sometimes you just have to rely on prom. So that's kind of thing I don't like. Can also make it a bit bigger. Beautiful arrangements. Beautiful arrangements. What if we call helper and then explicitly like pass numbers that we're interested in? So what if we pass like range 1 and plus 1? List range and plus 1. So this kind of thing, that's a helper method. I just want it to work with actual ranges. So it will return integer as well. So for okay, just let's say that A is like indices and B is like actual numbers, values that we want to put here. If A0 is divisible by BI, or BI is divisible by A0, actually okay, so how about we actually just pass 1? So A0 is like the first element that we are interested in. If either of this happens, then A should get plus equals self helper A0 plus 1, B up to I and B from I plus 1 and further. It should, like in here, it's actually one way it's arranged, right? And you just return A. Helper takes 3 positional arguments, but this should be plus. Okay, actually in this kind of problem, we can just manually test every input. Because n is up to 15. We can see no difference whatsoever, we can just submit. Save a couple of seconds on that problem. Merge two sorted lists. Okay, so L0 will be our output, And the way I personally like to do it is like L0 will be the actual head. It's a dummy variable basically at that point. So pre-L0 is dummy variable, and while L1 or L2, if L1 value smaller than L2 value, and here we'll have L0 is actually PL0. Here L0 next will get list nodes of L1 value, and L1 will get so L1 next. Else we put L2 in here. Then L0 is supposed to get PL0 next. We can delete PL0 and return L0. I think this is the expected way to do it. I would like to see the test results. Hello. Right, of course, if not L1, this is supposed to happen, else if not L2, this is supposed to happen, and only then we actually care about values. This is incorrect, because I also forgot to say L0 goes to L0 next. And this happens no matter what. So now we have everything in place. Remove duplicates from sorted list. We have because we want to delete duplicates, I believe we don't have to do it in place. So as usual, actually like interesting part that we only want to insert the value if next is different and previous is different. We kind of want 3 elements of context at the time. You know what? I actually don't think that we want to like do it by hand, so I will do just that. While head, right? I mean, we've done enough explicit manipulations with linked lists already. I don't think that we will learn anything from that, so now we have all values in the value list, and we can just iterate if I and value not equals to values I minus 1. Actually, if not I or value not equals, and I plus 1 equals len of values, or value not equals values plus 1, unique and well. What we actually doing, like we're checking like if there's no previous element or previous element is different, and if there's no next element or next element is different, then the value is unique. And it makes sense to append two unique values. Now we just need to construct back. So out next equals list node from well on gets out next. Out gets p out next. And safely delete p out and return output. Yes, because we did not call enumerate. Other than that, everything should be fine. Okay, this is the expected answer. Let's check that deletion works at the very beginning as well. So far, so good. Okay. Case missing positive number given an array of positive integers sorted and strictly increasing an integer k, or find the case positive integer that's missing from that array. Okay. I guess for I in range plan array. Okay, like answer is always in this bound, in these bounds, right? And we'll also ask for j, which will be 0. So if j is smaller than len array and array j equals I, and okay, let's say m is the upper bound for the answer, okay? And I will add 10 just in case. So we have j is the index in the array. If it is a valid index and value is correct, and we can just increment it, else value is not correct, and we can decrement k. If not k, we can return I. I suppose case means one based. This is correct. Let's just give it another test case from the samples. Feel pretty good about it. So we're saving a lot of time so far, partially because of Python, partially because I've been doing some practice over the course of January. Okay, so longest substring without repeating characters, substring without repeating characters. Sliding window problem, clearly. Now, okay. I must probably want it to be in deque. But at the same time, I kind of want what do I want? I want something else. And this something else means like a counter. Do I need an actual deck? I don't think so. So okay. Let's take collections counter, right? We'll have two indices. Left and right are like inclusive and exclusive boundaries of R. So half open interval, which denotes the current window. It will also need some sort of answer. I believe you can do it like that in Python, actually. So I kind of don't like when there are multiple statements on the same line. So, well, I think standard window goes something like this. Or actually, now that I think about it, we can do it like this, right? So, window at S or plus equals 1. It's like, actually in this case, it's default dict, really, of int. So, and here, no, let's do it this. While assets are L not equals asset R, also R will be incremented by 1 automatically. While this is true, assets L should get decremented and L should be incremented. We're trying to get rid of previous occurrence of the same character, and I believe this it should be L R plus 1 minus L. This n is not really used anywhere, but in this for loop, we can try something like this. Now this is not the expected answer. I suppose that we are actually like the better condition would be this, while this is bigger than 1, because previous is incorrect. Right. We have a bunch of b's as well here. This kind of string and also an empty string. I don't see any difference. I think it lagged again, and we have to refresh the page. Yeah, it happens sometimes, but not that much of a deal, right? And it should get loaded anytime. Network error. Oh, but my connection is actually good. Like I can test it on something else. Okay. So we actually want to submit it, right? Good. Check if two string arrays are equivalent. So given two string arrays, word1 and word2, return true if two arrays represent the same string, and false otherwise. String is represented concatenated in order from the string. What exactly is going on? Can't I just return this kind of string? Hey, hello. Oh, come on. I had to refresh again. Okay, so sometimes something like this happens. We just needed to concatenate strings in Python. It's really convenient. Here we have word ladder transformation sequence beginning from dictionary word list is a sequence of words such that first word is the sequence begin with. JSON, okay, only one letter differs. The shortest transformation sequence from 0 if no such sequence exists. That should be actually hard, no? I mean, we have 5,000 vertices and we want to run Dijkstra on that graph, right? No, we don't want Dijkstra because all transitions are one character long. So the simplest thing we want to do is BFS, right? BFS will deck you of only I don't like this at all. These names, like whoever calls variables in Kamil case in Python. We'll also need a scene set. Actually, let's say distance. And so we will just run BFS and we can afford being sort of inefficient but more explicit. I think it helps only in this situation. Distance to source equals 0. While BFS is not empty, we can take front equals BFS. I'm not exactly sure whether pop left returns the elements or it just, I think in Python such pop functions usually return element, but I may be wrong. So we actually want to build the graph as well. And we can afford it, can afford to build like not very quickly in the following fashion. If distance vertex other equals 1, we can say that graph vertex ends. Now we have to define distance function. So one way to do it is the following. We just count how many pairs of characters there are that don't match. And we can do it by zipping our two strings and then just count. So here we define distance function. Here we build the graph. And I think we can do it even like this. Just to be Pythonic, sort of. Now, we pop left for adjacent in graph of fronts. Oh, we can remember two vertex. Front is rather C++ habit. So if distance, show distance. No, we can't. Okay, so if dist at adjacent is greater than dist at vertex +1, it makes perfect sense to BFS fans adjacent, and of course to reset the distance to the correct number. This kind of thing does not look very efficient. Key error hit. I think we are supposed to and source and destination. And the problem is that we have dist destination transactions, but +1 word. So let's also test on another sample. We were expected to get why actually like to cog you can get from doc. No, wait, heat, hot, doc, cog. So cog is not in our word list. Interesting, so we don't append destination. I think I may get away with the following. Wait, think. So if I just make it a default dict. It is slow in the place where we built a graph. And I have like better ideas. Okay. So potentially like calculating the distance between every pair of words is too much. But it's a bit annoying. I think that if we just rewrite the same thing in C++, it will pass, which means that like basically bad time and everything. Destination, and here we expect to have a vertices, right? We will now push back source. distance is still possible to implement this way, but we'll need explicit summation, so its L will be word 1. R will be answer. And then we just iterate explicitly. It's kind of unfortunate if we will end up solving this problem just because we switched to C++. But again, it's nearly impossible to guarantee that every approach has consistent results in different languages. I just don't want to make it very long. So actually it's not okay. It's actually an ordered map from string to vectors of strings. And because of that, for vertex in vertices, for also, yeah, we just do the same thing. We iterate our pairs if distance ref vertex. We can also like speed up things a bit if we change, no, not a bit, by a factor of 10 if we change vertices to actual IDs, right? This is not the kind of optimizations that I want to do, so. This is the expect way to do it. Also add it to destination. We can also add it here. Here we will change solve and solve things. So I have our distances initialized, I believe. We have our deque initialized. Distance at source will get 0, while node BFS empty. We'll take front and BFS pop front and iterate over adjacent vertices. If distance is small, we update it and push. It's not actually all that long, right? No, it's sort of long. Numeric limits here, here, and here. Wait, but I printed the answer. I'm sure that I printed the answer. Well, that's interesting. Okay. There is a way around it. So basically we want to have like vertices. So vertices will be list range words. Okay. Len and words. After we do this small change. So this stays the same, but here vertex and vertices. Yeah, I believe now it becomes clearer to change to actual indices instead. Like this thing is not actually slow, right? But here we'll need to find the ID of the destination. And I think you can do it like this, words index destination. Also, yeah, let's just say it from the very beginning, if destination nodes in the words. This way we are pretty guaranteed that destination is somewhere here, somewhere in words. So this should be like 10 times faster. Is it still TLE? I feel like it is. But like 5,000 times 5,000 times 10. Okay. What if we do something like this? R equals 0. 4 R plus equals equal to 1. If R greater than 1, return false. This checks strings up to first mismatch, up to second mismatch, sure. And I know there's like one more. Okay. Okay. That's a strange kind of question, but it happens. So L equals what? Should I call it like N? Vertices size. After I project. If vertices find destination equals 0. No, extra equals vertices in, right? Now we are fully prepared for whatever comes next. Oh, okay. And then it's again a vector of integers. Here we have kind of. Or actually, we don't have to do that when we can simply do that. You don't have to set it separately because we already checked that. And BFS equals BFS is not equal source. BFS equals distance vertices begin vertices find source. I think that this is what source is supposed to. And then the same thing actually can happen with destination, right? Take it from the front, we iterate, we do the same thing, but here destination should follow the same pattern. Do I have to find vertices begin, vertices and then source? That's not really nice, but it happens. And yes, it's really not the nothing special about vector class, right? And again, right? Why? Because this is a graph of integers, of course. And we also want to give him some size. Oh, we should not have overloaded distance like this. Oh, okay. Yeah, we can't like convert just like this. too many adjustments to be made. Wait, it can't be time limit exceeded. No way. It has to be fast enough. Come on, like 5,000 times 5,000 times 10. No, you're kidding me. There's no way it's too slow. I mean, I kind of know what else we can do. Okay. Obviously, this does not work because it's quadratic in terms of edges. What we can do is instead is use the following. So, but wait, no, it's like just stupid. I had, you know, like, because there are only 26 letters in the alphabet and only 10 letters, there are only 250 neighbors at most. But like generating them in C++ will be so much pain. Oh man. Really? Like just really? So we have IDs, right? And we have that graph. I'm actually surprised. And this did not fail last time because it should have. S is ID source, D is ID. S here, S here. Destination, yeah. For so we want to change this, right? Up to J plus. That's our adjacent, right? If adjacent in IDs, graph at I and just actually IDs adjacent, right? Hit code. agree. It's supposed to be this. In range. If this does not work, then I don't know what is expected. Like, okay. I honestly did not expect tests to be good, and I still think that like 250 millions should pass. And I'm assuming that it does not pass because of the strange time limit system on LeetCode. Because like for one test, it's more than enough. Because many strings will end early. Right? Anyways, sometimes it happens. So we are not all that faster now, right? Spend a lot of time. Create sorted arrays through instructions. We give an array instruction asked to create a sorted array from the elements. Start with empty container for each element left to right an instruction insert nums. Cost of insertion is minimum of the following numbers, strictly less, strictly greater than. Okay, I will solve it in C++ using some cheeky solution. You'll see what I mean in a second. Let's switch to English just so that you don't feel like you don't understand anything. I will just use the power of C++. I hope that LeetCode uses GCC, because that's exactly what we'll be using now. Strictly greater, strictly less, very good. And then we just need to copy that class. So this is like order statistics tree from the box, which is really convenient. Now what we can do is we can create ordered set and 16 int cost and also int mod. Cost initialized to 0, return cost. For we just iterate through instructions. We'll take that thing. Order of key, I believe, is the correct methods. Cost plus equals mean. I think that something like that should pass. It may or may not be correct. We'll see in a second. The main concern is that LeetCode needs to have GCC specifically. Instructions, that's my mistake, I agree. Too soon. How could I? Okay, it just happens. So did not compile this time. You know what, we can just always print k and n minus k on separate line, also print separate line here. Because samples have explanations, we'll see. Here we should 0, 0, 1, 0, 1, 1. So the second element is not correct. So the second element is not correct at the moment. I'm assuming it's because it's already here. We can get around. We will just we'll just have two such sets with different comparators, and then actually, I'm not sure. Wait, should not be a problem, honestly. I'm a bit concerned about duplicates. So here we get correct values so far, then we should see 1, 1, which is incorrect because, oh, it's concerned with how many numbers there are. Okay, it's not a big deal. We can just have pairs. Then this time well, I think it's a bit overkill and there is a simpler solution to this. I want to think. I know that this is solvable in one way or another. So what if we have pair here, pair here, pair here, pair here? And what do we get now? We get too much. We're interested in. I'm thinking this is because we need actually to do something like that. Either this way or the opposite. So it was the opposite way, okay. Well, 3, 5, 0, 4, okay. Should be good to go now. That's this is some cheats. I understand that you're not happy with this cheats, but Wow, what the heck? Excuse me. Oh, I did not read that constraint. Oh, okay, obviously because of that constraint we can maintain frequency table. But hey, like this should pass as well. What do you mean it does not pass? For you to understand this data structure support all operations in logarithmic time. So basically 100,000 elements in 1 second is not a problem for them. So there's something real strange going on with LeetCode time limits. I don't know, maybe they like, excuse me, camera, please focus, thank you. So yeah, it's just strange, What is the actual like expected way to do it? Because instructions are small, we can create frequency table, but we don't want frequency table. We want to find sum on prefix and sum on suffix. Sum on prefix, sum on suffix. Well, sum on prefix basically, because sum on suffix is pretty easy. Now when the sum on prefix, but you need a fanfic tree for that, really? Like, beyond a cell intense problem. Really? Is that what you want me to implement? I don't want to implement, no. You know what, I'll just copy my fanfic tree. I'm that lazy. The whole purpose of fanfic tree is that you can write it like very quickly, but I will just copy it. Yeah, you know, it's been a long month, so I hope you will forgive me that. Where is my fanfic tree? Sure. It's in C++, that's fine. We can live with C++. So we don't need that, we need fanfic tree. Fanfic tree has a bit of an interface going on. I have to, no, actually I think I know the interface, like sum is from left to right, assign at assign. I don't need to sign, I will just increment in this problem. I don't actually need sum from left to right, so I will just do that. Sum from left to right can also be ignored. Have initialized string increments, okay. Want to call initialize? Or do we have to call it so like, no, constructor resizes everything, okay, so. This was incorrect. I need something like this. Also, int cost will be here. Oh, no, I forgot. So fanfic tree can do the following. As we iterate over all instructions, fanfic tree can get some instruction I, which will be like smaller. This is the count of numbers that's strictly small. Greater will be I minus small. And we can increment that instruction by 1. And to cost, we add minimum of smaller and greater. And if cost is actually greater than or equal to mod, then cost, we subtract mod. And then we can safely return cost. Why no viable constructor? What? P is int by default. I agree. Well, this is incorrect because here we don't want this. We want this plus 1 instead, because we want to strictly greater numbers. Well, this is still incorrect. But this is incorrect. Oh, maybe you're actually interested in querying for that. Then here we're interested in querying for that. Yeah, these numbers look as expected. I guess with the same level of success, I could just submit, right? Because now everything is like, okay. We'll simply reload. At the very moment when I reload the page, it loads in. Like asymptotically, this is the same solution, but for some reason, it worked better. Okay. Now we have to merge sorted arrays, and we have 2 arrays, so we want to merge them. No way. No way. You expect me to in place merge? What the hell is that? Honestly, like, who cares about in place merge? Isn't it slow? Just since there's a stupid algorithm that does it, which is implemented in STL. Like whenever you actually need to do it in place, you just use the algorithm from the library. What kind of thing is that? Very disappointed, and because of that, Can I just do like that? Is this legal? You know what? I don't even care. I don't like your problem. So that's your problem that I don't like your problem. Okay, but anyways, add two numbers represents the linked list in reverse order. I'm not even interested in that kind of thing. How about you've probably seen this problem like a million times already? And I see no pedagogical point in implementing it again. So we'll just copy paste our solution. You know the trick, you have to keep track of the carry, like how much do you have to carry, then you have to like stop at the correct position, but I believe it's like first or second problem only it counts. Seconds. Well, pretty much everyone solved it already, so it does not make sense to have C++ solution. I have Python solution on its own. So what we do here is we say that we'll construct new list with our standard technique of like to return and we say like, hey, we'll have like pointer to the current node in what we will return. I have carry while list one of the nodes has one of the list has a nodes or there is some carry. We go and use it. And in the same way, we like go to the next one. Actually, I believe that this can be done here. And this can be done here. Am I correct? Simplified our solution a bit. Honestly, there is nothing interesting here. Like you solved this problem already. But to save people, we're given an array people where people I is the weight of i's person and an infinite number of bots where on each bot can carry a maximum weight of limit. Each bot carries at most two people at the same time, provided the sum of the weight of those people is at most limit. Turns the minimum number of bots to carry every given person. What about we just put everything into a set of integers? Two people, yeah, into multi-set of integers. Oh, no, actually, like, what I wanted to say is the following. Let me take the person of the maximum weight, right? Oh, yes, we can do it with multi-sets, obviously. Well, not, while we have people here, we say like, heaviest will get people, we get ourselves heaviest person from the multi-set, right? And we can raise that pointer. Then what multi-set can do is it can get lower bounds. On limits minus h, the only issue is that I actually want not lower bounds, but like previous element to that. Because previous is the max that we can put inside. There will be some dirty tricks. Okay. What we essentially can do is we can just use a trick with negative sign. If we insert minus person, in h can get begin, because begin stores max. H is negative weight. So this is the actual weight. Now, if we search for that, is it guaranteed that people? Okay. So limit is at least people. Yes. Okay. Now this will be the first person that we can take. So this is a pointer at the moment, because if p is not equal to s and s raise p and plus. Okay, this is correct. We should run one more test then, as simple as this, and see whether it's actually correct or not. So far, so good. Let's submit and check. Okay, we got accepted. Minimum operations to reduce x to 0, given an array number. One operation is to remove the leftmost to the rightmost element from nums and subtract value from Rx. I think it was in a recent contest, no? We're interested in a minimum and maximum prefix sum to work with it. Right? Now, actually, we will remove some prefix and some suffix. Want their sum to be x. And because want their sum to be x, and suppose we know the left value, so the value of the prefix. That was that. Then we can just do binary search over suffix sums, because nums are non-negative, and therefore prefix and suffix sums are sorted. Do partial sum nums sorter from P, I believe. Same thing from R begin to R. If it's impossible, return -1. So if return a equals n plus 1, should be this sign, -1, a. Want to check for x prefix at I, right? A should get mean of a, then distance from as begin. So iterator plus I believe something like that. Why there is actually no? Do you want me to cast it to integer like that? Interesting, very, very interesting. Or maybe we don't want to reverse. Yes, okay. May still be offline by 1. Let's see. Or did it reset the tests? I mean, okay. We are half an hour faster than the previous time, but problems are different, so maybe it's because of that. But we also observe several problems that took us longer to solve, especially word ladder and create certain arrays through instructions. Again, next in generated array, we have that kind of array where to get max. N is up to 100. I see no point in not generating array ourselves. Let's copy the rules here, actually. Now the size will be n plus 1. Next we can do this and this. Actually, n can be 0, and n plus 1 is only 1. You know what? I'm not playing these games. I will do it like this. Can just go to specific locations that we want to check against it, right? So see 2 times I gets nums at I. just the same equation, and nums at 2 times I plus 1 gets nums plus nums at I plus 1. Only have like one, no, actual nums plus 1 is always defined by the time that we ask for it. So let's just get a couple of samples. Hello, can you please run it in samples? Unfortunately, like in my experience, if you try to use LeetCode for like an hour straight, it gets kind of weird. That's an interesting observation. Maybe it has something to do with like rate limiting users. No difference is detected, we can submit. Case largest element in sorted array. Yeah, but like we can just I know there's a specific linear time algorithm, but in C++ nobody will ask you to write it. I'm not sure whether or not we are supposed to dereference that iterator. Okay, potentially we are supposed to return that thing. Yes, it just does not return anything, and we basically we have to do that thing twice. It's okay. Wait, is it k minus 1? I think it's k minus 1 because k is second largest, by the way. Second largest. Is it really what we want to get like this? We'll get this. I think what we want to do instead is this. Then where is that specific location? Why? K equals 2. I ask you to go to what index? 6 plus 1, 7 minus 2, fifths. Or maybe I just don't need this plus 1. What do you think? I don't understand. No, like look, n is equal to 6. K is equal to 2. So we get 4. Get 4 from first, which is this position. This position has to be correct after this. I know we can just sort, but I believe this is much better solution. So we'll try to get it to work first. So what is our array of numbers? Why? So it got rearranged. But force element is not force element. Maybe, I don't know. Maybe, I don't know, C++ and then some. Tense element should return some, does not return anything. That's correct. The order is different. You have to pass this iterator here for it to work. Which is kind of reasonable. You pass iterators in the expected order, in the their actual order. I lost a couple of seconds here. Count sorted wall string. We're given an integer number of strings of length n that consists only of walls and our lexicographic sorted. Yeah, well, actually, why am I doing this? Okay. Of length n. Right? Actually, I need to take a break because. So yeah, I'm back. I did not pause the timer because last time I actually, when I took breaks, I paused the timer and people said it's not really great. So this time I want to pause the timer. This is typical DP problem. What we'll do is the following. Like DP at ij will denote the number of sequences that end in i's vowel of length j. So then we just want to return sum of dp minus 1, I believe. And the last place. And then you just want to do something like this. Like what you put here will figure out some. I believe we can do something as to put as this. So k has to be at least j. And we can add pj here. One, 2, 3, 4, 5, 6, 10, 350. D is not defined. Where is D? Here is D. And now it's not right. Hello. Cool. Not really cool, but we'll get past it soon. Right? But my network connection is fine. I just got a message in Telegram. So it is something about LeetCode. not me. Last time it was much worse, I remember. This time it's fine. Subject is right, because what we actually want is we want to put it in the list. What it's just complicated to think about this way. So I will just do it like this. Okay. Now it's like again. What the hell? No, like honestly. And I mean, I'm using LeetCode for free, right? But there are people who pay for this. I still think that like LeetCode does a great job in terms of providing a lot of free content. But obviously this platform is not about being free. We want to make money out of you in particular because they have to maintain stuff, right? So this kind of approach is not bad, it's like natural, but it just means that some things will be wrong. So despite having a break, we actually not that down on the timer. Max number of case sum pairs given array integer k in one operation can picture. Remove them from array, returns maximum numbers. Form on array. Okay, what if I just take counter nums for key C items? Answer will get 0. I will return answer in the var ends if actually m will get a mean of c. One exception of if 2 times k equal k is this, okay, whatever, x. Oh, I don't need value, to be honest. What if I just do it by 2? Else m gets smaller of these two. X minus k. Ck gets decremented by m. Cx minus k gets decremented by m. A plus equals m. Let's grab ourselves another test case. Actually, around that point last time, I got really tired and my head was already aching. This time it seems more or less fine. After months of practice on different platforms, I don't experience any kind of difficulties. And also this time we did not skip a problem in the beginning. So we're clearly doing better this time around. Apart from having apparently network issues. Kind of happens, and these network issues remind me of yesterday's code stuff. Like, in my opinion, obviously issues were dictionary change size during operations. In my opinion, everyone knew what the into, and it was expected that some sort of 503s and Jinx not allowed 415 will show up. So it's really strange to see it generated because like I was frustrated by it, but I just continued working on problems and got away, submitted 4 problems, experienced a lot of issues, but still submitted 4 problems. Just fine. What do we want to do? Longest palindromic substring. Man, I'm not interested in implementing it from scratch. There are multiple algorithms. In particular, you can start at any position and expand to sides, right? But I believe that if you are interested in this kind of questions and you already implemented it, so I just don't feel like wasting time on it. Yeah, that expansion algorithm works just fine for size of string up to 1000 because it's quadratic, and generally is quadratic in practice. Solution is unnecessary. Yeah, it's one of these problems, and it is solvable in linear time, I believe, with the help of prefix function. I'm assuming that I actually implemented linear time solution. Did I? Or it looks like a sliding window, actually. Well, I don't care particularly. There are multiple different solutions that will work. I believe that my solution to that kind of problem is not different from yours. Yeah, just skip not interesting problems. Valid parentheses. Determine if input is valid, closed. Okay, simple stack problem. Well, let's have stack. Have a dictionary of pairs. Like this maps to this. This maps this. Maps to this. And this closing parenthesis maps to, I forgot about that part. This closing parenthesis maps to this. So we have a stack for, we iterate over this, and if that's not an param, then we append it to the stack, else if stack and stack -1 equals pair, that characters in the pop from top, else can immediately return false. If everything went fine, we can return true. Interesting, because here we have to return a not stack. I forgot about that property of being balanced. No, it's slow. It's lagging again. Okay. Yeah, I forgot. I definitely forgot that you have to check that stack actually becomes empty in the end. That was unfortunate. I guess we'll just refresh page until it shows up. Oh, interesting. I have to check something else while we are reloading this page. Oh, what? No, I did not click. Oh man, that's annoying. Yeah, I must have clicked just tiny little bit on the solution by accident. Now it's accepted. We are almost an hour down on previous time, so that's a good sign. Most competitive subsequence. Wait, so we want like lexicographical and minimal subsequence, right? Isn't it just mean stack? Okay. What is K? Of size K? What? How is that possible? I mean, like, if you want to just most competitive, then you can. Then your answer is mean stack, right? If you want more, and I have no idea. If you want to fix its size, and I have no idea. Well, that's strange. I'm just interested. I definitely have not solved this problem before. I just want to check how exactly difficult it is. Oh, and it, right. Edit layout. I forgot that it shows December. Man, hello, where are my splits? Right, it's January. I think it's hard. It should be hard. No, it's medium. It's medium and it's recent problem, so it was in contest, right? By the way, how many new problems did we solve today? This is kind of interesting, I think. I believe this number was smaller, but not by much. Okay. We want to find the most competitive substring of given length. Isn't it the same mean stack? We just can't remove elements if the result will be too small. Yeah, I think it's the same mean stack. But we can't remove elements if the result will be too small. Okay. Smaller than stack minus 1 and length stack plus minus or equal to k. Is this it? We just make sure that we use the same mean stack. We just make sure that we don't pop too many elements from it. Hmm. Hello? Oh, it got laggy again. Like literally in the different window, I just refreshed my bank account and it worked just fine. So it's not my problem this connection runs. Just LeetCode being slow today. Interesting. No, not here. I wanted to. Yes, here. So apparently this is not enough. But greater than K. Yeah, maybe this is enough. Determine if two strings are close. They are close if we can obtain one from another using the following operations: swap two existing characters, transform every occurrence. Okay, nothing interesting here. I may be wrong. Yes, like overall idea is correct, but I want to be more careful about what I do. What I actually want to do is like frequency map is the same if you disregard keys, but keys are the same as well. Set of keys is the same. I believe it would be faster. Like I don't want to submit because then it can freeze again and feels like we get network issues not that often when we run compared to when we submit. So we are more than 1 hour done from our previous time. We want to sort metrics diagonally. Honestly, no. Guys, like, we know I can do it. We just generate diagonal, sort every diagonal, put it back. It's not interesting. I believe I actually already solved this problem on some sort of stream. So we'll just copy the existing solution. Oh, it's kind of hard to sit for 2 hours. Yeah, please wait. I know it is here. I know it is here. Oh, they actually added a video session. Yeah, and I've seen this whole thing going on with video solutions. I believe that my submission is in C++, yes. Yeah, so we split into diagonals and then we combine diagonals back. This is just classical, too classical for me, I don't know. merge k lists. There was that trick. Definitely was that trick with. Okay, I mean, how I actually solved it already, I'm not sure. I kind of think that I did. Yeah, honestly, I got a bit tired of this. So. The idea is obviously to use the heap, which I believe all of you are familiar with. So again, the educational value is not high. I'm not exactly sure what is the educational value of like the entire video. But yeah, it's like one of the first 100 problems, so it's not particularly interesting, I guess, to see me coding it. Yeah, we use heap, push, pop. Nothing intellectual, really. List k places away. The way we will do it is the following. Max. Then we wanted the opposite. All are at least y exactly. Ah, he mean k empty places and not k spaces. No. I keep forgetting about that kind of thing. Pass with minimum effort. No, we already solved this problem on some sort of string. Pretty sure that we did. That's a classical DP. Don't have, or maybe you have to optimize it a bit, but I don't think so. Yeah, it's a recent problem. Maybe maybe it was even some sort of contest. I don't know. Like two recent problems and very old problems I don't want to cover. They're not interesting. Or maybe it was, yeah, it feels like my submission from the contest. L. One of the reasons why I don't want to implement it again. We are like almost, well, I know it's a bit like strange, but like if you follow what goes on LeetCode, then we probably don't want to see problems as it were like yesterday in the contest, and you also don't want to see problems that are like first 100 that you already solved. So I'm trying to keep that shorter than 5 hours within last time, and at the same time I'm trying to solve like interesting problems, or at least the problems that are super quick to code and may have some educational value. Yeah, probably they have some sort of rate limiter which really kills speedruns of that form, but so even enter and return decimal value of the binary string form, but concatenates the binary representation of 1 to n in order modulo 10 to the 9. Excuse me? How on earth? What? Like, no, okay, we obviously can concatenate them, right? I'm just curious, what will happen if you do exactly what is suggested? The total length of this string is not very huge. Each number has at most 6 digits. So the string we don't want that. We actually want like binary of it starting at position 2, which may be kind of a problem. I mean, I'm guessing that you can. What? I don't understand. Or maybe they want me to convert to base 2. This should like die on 1,000 or 10,000 at least. It should be really slow. What about 10,000? Oh, it's still very fast, so maybe we am worried for now, at least. And now it's stuck. No, it's accepted, so nothing smart here. Just Python. Smallest string we are given with a given numeric value. Numeric value is 1 index of lowercase. Okay, that's not particularly difficult. K is this. Okay. That plus 1 is actually already added. 5 and 73. I think we can do just this. The complexity is n times alphabet size. In K, no, like here we can have up to 26 on this. If this is fine, then we do this and K gets incremented by this. Let's be explicit. Value gets this, K is decremented by this. N minus 1 minus I. Something is clearly wrong. You would like to subtract minimum value. If then by adding 26 times this we can get away with it, then we want to do this. Value is here, okay. Okay, now it should be good. Takes quite some time to judge. What? Why? No, I did not click here. How is that slow? Yeah, okay, I have an idea. This kind of trick speeds up significantly. Should not be getting incremented by L, by letters, it's L. Yeah, so like each next letter is at least the previous, so we just use this and keeps track of minimum letter that can be currently. Yeah, we are very good with like 2 hours of the previous time. Vertical order traversal of a binary tree. What? The heck is that? Okay. That's really strange. Low and calm start in 0. kind of need that kind of thing because I want to do that. I want to sort them by column, right? Root left has row +1, column -1. Root right has that. DFS from root. What's actually we want to do now? What is the output format from left to right? Leftmost column to rightmost column. Suppose we take values items, we sort them. Right? Then we can discard. No, here like we have error. Okay. In values items, right? Suppose we already make them sorted. Column is a dictionary from R to this quickly gets out of hand. Anyways. I think this is what we want. I think so. It's like an in-game. I guess you can easily subtract 10 minutes from our time because we were refreshing the page now, and now my tests are done. Not enough values to unpack column values. I didn't understand what happened. We were expected to put it here. Or is it because we want column items? And then it's lagging. Superb. You know, it's not my connection. Like I'm working in a separate tab as well. And it's just nice. Okay. Minimize deviation in array if element is even divided by 2. If element is odd multiplied by 2, we want to maximum difference between any two elements of array. Okay, what I think we can do. No, not that quickly. First things first, what if we just divide everything by 2 while it's divisible, right? Then what we want to do is, like, we have several odd values. What is the optimal way to get them together? It's to increment smallest ones until it makes sense, right? Also, you can say that nums get set of nums. No, but then, like, what I want to do is a little bit different from what I am doing now. That's strange. You see, the problem we're facing is that I'm too used to working with sets as in C++. Fortunately. Or actually, that was stupid. What we can do instead is iterate with reference. Well, by 2 divided by 2. Take the set. While is begin 2 times as begin subtract as begin. Smaller than. Max of this should have higher prior, right? Actually, max should be here. Feels like we can just check this condition while this condition holds. It makes sense to multiply first element of S. about something like this. So the point of this condition is we just check what will be check what will be the max difference after what we did. After we multiplied smallest element by 2. What exactly is undefined? Can you please elaborate more? Do you want me to put max here? Okay. Actually, let's submit straight away. Interesting. Here our output is 2, but answer is 3. Let's think why our answer is 3. So if we take this, so our set is what? Is 1, 5, 3, right? And we say multiply 1 by 2. We'll get 2, 3, 5. And we multiply 2 by... Oh, man. No, wait, no. Why the answer is 3? Because I won't be able to multiply this out. What the hell is that problem? It just became much more difficult. Wait a second. Like, it's too difficult if what I'm thinking about. Not that thing. This is actually difficult. I don't know how to solve this problem. Is it hard? It's hard. And I don't know how to solve it. Like, I saw that we can divide and multiply whatever 1 by 2, then my approach works, but this is hard one. Yeah, it may be beneficial to actually take a short break. We will still be under 3 hours, I think, safely. So I'll pause it here, but I won't pause the timer. This is not correct. Yeah, so effectively I'm trying to do more or less the same thing. Just a bit more accurate with operations at the moment. Wait, I don't know what exactly is wrong. But let's auto convert. Maybe this part is wrong. No, I'm still worse. Does not always make sense to divide by 2. This is kind of hard. What kind of condition I want here? Do I want this? And now it's lagging. Now it seems better. Some random test cases fail. Maybe we want to take max of these two, or min of these two rather. Lagging again. Yeah, some of these questions are kind of hard. Really hard. Or maybe I'm just missing obvious things, I don't know. I hope we still can finish under 3 hours. Next permutation, we're just going to copy paste it. It's a well-known linear time algorithm that I have no intention of implementing again. And we will never implement except for interviews. What is that? It just does not want to run my submissions. But I want to run it on tests, in these tests. It's not getting any better. What I'm trying to do is like take max. If dividing max by 2 makes us any better than divided by 2. And then we'll take mean. When multiplying mean by 2 gets us any better, multiply mean by 2. That's all I'm trying to do here. And I'm constantly updating minimum difference that I got. So apparently something here is not correct, but I have no idea what. Non-error. Go. It's still bad. I don't know, people. What am I supposed to do in this kind of question? Why it actually fails? Well, I don't think we will understand from this kind of input what actually failed. Which is really unfortunate. I'm just wondering. No, it's not like it's illegal, right? I know it's legal, but I just want to know how many test cases we actually fail. Okay, so we only fail like 2 test cases. I'm not sure why. Maybe in 64T somewhere. How about that? Is it possible? No, I believe I use in 64T everywhere where possible. I don't know what exactly is wrong. No, actually. Well, this. Yes, something is wrong on the large test case, but I don't want to. Hello, can I please? Oh, my must copy it like this. Apparently. Yes, this is illegal. Like, you won't get away with it in the contest, right? I'm not exactly sure what is not working. Should read a solution. Is it only for premium members? Well, that kind of sucks. I guess we'll just quickly submit next permutation because it's not an interesting problem. Yeah, someone first 100, so you are not doing it live. Yeah, that's algorithm. Exactly this one. So, with some copy pasting of trivial questions and with some cheats, this problem we got away. We did the entire challenge in 2 hours, 54 minutes and 35 seconds. Let me actually make myself like that. Okay. So there were several problems that we did like badly on, including a pre-last one. I'm still not exactly sure, like idea is more or less this, like you, while dividing max by 2 makes it any better, you want to divide. Once you can't divide max, you have to multiply mean, right? What exactly is wrong? I'm not ready to investigate that matter. Couple of interesting statistics, like 2 hours and 45 minutes is actually 174 minutes, which means that we, and there are 31 problems, which means that we spent on average 5 minutes, 5.6 minutes. Let me actually convert everything into seconds. So 5 minutes, right? And 38 seconds per problem. I think it's not bad. Like, obviously there were things that we could do better, but I think it was pretty reasonable time. And I also hope that you don't mind that we copy pasted some solutions, because I really feel like these were just too obvious. So yeah, that was it for today. And I'm guessing that we can kind of end our January speedrun here. And maybe I will post my back down in the comments for this video. So yeah, where is it? Okay. So yeah, thanks for watching and bye-bye. No, I'm trying to take a thumbnail. I'm not sure that we, oh, I should just like sit like this. Right, it kind of looks good, kind of. Okay, so yeah, this was it for today. Let me just make sure that it copies correctly. No, this kind of face is kind of strange. This is strange. No, this. Yeah, okay, this is better. This is clearly better. Okay, I think this is it. Thanks everyone for watching. Hope like this minimalistic explanations helped you, and see you next time on the working week with some code forces trainings. Thanks for watching. Bye bye.